All right, so in this video, we're gonna learn how to evaluate your rational expressions like multiplication and division. So let's start with this multiplication first. We're gonna multiply two rational expressions. Here we got 2x over x plus 4 times x squared plus 5x plus 4 over 4x. So in order to multiply, we need to cancel like terms, and we need to factor first. So we got 2x, but here we have 2x over x plus 4 times, and the other fraction here we have x squared plus 5x plus 4. So this polynomial we need to factor it first in order to simplify. So since we have a, which is the coefficient of x squared, is 1, so we can just have two parentheses here, and we can have I don't want to mix it with multiplication. Let me just do it exactly like, it looks like x here. So we're going to have x here and x here, and we need to find two values whose product is 4 and whose sum is 5, right? So again, I need to find two values. Let me do it separately here. So I need to find two values. So whose product is 4. So two values, you multiply them, you get 4, and we add them up. We're supposed to get 5, right? And clearly it's going to be like 1 and 4, because 1 times 4, it's just 4, and 1 plus 4, that will be 5. So it's going to be like x. So that will be like x plus 4 and x plus 1, because 4 times 1 is 4, and 4 plus 1 is 5. Divided by 4x, right? Well, now I think we can simplify. We have something to simplify here with, right? So we can just simplify x with x will be gone. And we know that 2 goes to 4 like 2 times here. So we're going to have 1 here and 2 there. And x plus 4 will be gone. So what do we have left there? So we're going to have x plus 1 over, and here we have 2, right? And keep in mind that we have x plus 4, right? We have x plus 4 and 4x. Those must be different than 0. So we can find also the restricted values here, that x plus 4, right, must be different than 0, and 4x also must be different than 0. So x must be different than -4, and here we can just divide it by 4 in both sides, right? So x must be different than 0. So -4 and 0, those we can call them as restricted values. Means the domain that x cannot be equal to 0 and -4. So here we're gonna evaluate those rational expressions. So we have division. We're gonna divide the first rational over the other one, which is 3x minus 9 over 3x divided by x squared minus 9 over 9x plus 3. So when we divide two fractions, actually we have to keep the first one. So we're gonna use keep, change, flip. So we're gonna keep the first one, right? So we're gonna keep the first fraction, and we're gonna change the division to multiplication. Then we're gonna flip the second fraction, which is gonna be like a reciprocal of the second fraction. So we're gonna keep the first one, which is gonna be 3x. So it's gonna be, all right, so it's gonna be like 3x minus 9 over 3x. And we're going to change the division to multiplication. So division will be changed to multiplication, right? So we're going to multiply here, and we're going to flip the second. Fraction, which will be 9x plus 3 over x squared minus 9, right? And and now we have to simplify. But before we simplify, we need to factor first. I mean, we cannot simplify like 3 with 3 here. Why? Because we have a minus here, right? So we need to simplify. We need to create factors, right? So let's try to factor the you know, both the numerator and denominator here, right? So let's do this one here. So we need to factor by, let's start with the first one, 3x minus 9. So we need to factor 3x minus 9 by finding the GCF, so which is the greatest common factor, and it's going to be like 3. Now 3 will be a factor of x minus 3, because 3 times 3 is 9, and 3 times x is 3x, over 3x. And remember, here we're going to multiply again. Now 9x plus 3. The common factor is going to be 9. It's going to be 3, which is that's the greatest common factor that is shared between two values, between 9x and 3. So it's going to be 3 as the greatest common factor. And that will be, if we take 3 from 9, we know that 9 is 3 times 3. So it's going to be 3x plus, remember, he's like I have 3 times 1. He's like I have 3 times 1. So if I take 3 here, I will just have 1 here. I will have just 1, right? Because 3 times 1 is just 1, over. I got x squared minus 9. Now that's called the perfect square. And let me just remind you here about this property of a perfect squared. If I have like a squared minus b squared, that will be a minus b times a plus b, right? And I have here x squared minus 9. That's going to be x squared. We know 9 is a perfect square, which is going to be like 3 squares. So 9 is 3 squares. So we can write this one as x squared, as x squared minus 9, which is 3 squared, right? So it's going to be like x minus 3 times x plus 3, right? So we can use this, you know, the difference of square property, and we can just like simplify x. We can factor x squared minus 9. So that would be x minus 3 would be x minus 3 times x plus 3. All right, so let's try to simplify some like terms here. So we have 3 with 3 would be gone. We get x minus 3 and x minus 3. And that's it. That's going to have, so we're going to have 3 times 3x plus 1 over x times x plus 3. All right? And that's going to be the answer. Well, if I want to know the restricted values here, that all the denominators here must be different than 0, right? So 3x, I mean, 3x should be different than 0. We get x minus 3 should be different than 0. And we get x plus 3 should be different than 0, right? So if they ask you for the restricted values, you're just going to solve for x here, right? For example, the first one. So the first one, 3x equals 0. You divide by 3. You're going to get x equals 0. So that's one of the restricted values, right? If I got like x minus 3 equals 0 means x should be equals 3. And if I got x plus 3 equals 0 means x equals negative 3, right? So those like the values of 0 and 3 and negative 3, those we call them restricted values. All right, so we call them restricted values, right? That means x cannot be equal to 0 or 3 or negative 3.